Hello, everyone. How's it going? Welcome to the part 3 of Finance with Python, where we are learning about Python, but by diving deep into the world of finance. So, yeah, welcome back, everyone. Uh, and hello to everyone who's joining me for the very first time. I will, of course, wait for a couple of minutes for folks to join. But meanwhile, if you are here and if you haven't registered for the session, please do so. I will share the link in the chat. Hi, everyone. Hello. Uh, Step one, please do register for this session. It helps you, it helps me, it helps MLH, it helps everyone to keep track. This is how you'll get your swags, okay? Your check-ins, all these things. Uh, so yes, please do register for the session. And anyone who's joining, hi, hello, uh, good morning, good evening, good night. I don't know. Uh, for me, it's 8 p.m., nearly 8 p.m., I would say. Uh, for others, it could be something different, right? Let me just set some background music so that you don't get bored of listening to me. Good one. Just on a very low volume. So it's there in the background, but it does not disturb us. So, what have we been doing? As I said, this is part 3 of Finance with Python. So, part 1 and part 2 have been very eventful. Okay. So, whatever we have done, thankfully, is actually available to you on GitHub. So, I have posted and sent, uh, not sent, uploaded everything on GitHub. And from the looks of it, it looks like there are at least 8 people who are actually working alongside me. Okay. So, thank you so much, I would say. So, what we have been doing is we have been diving deep into Python, right? So, not exactly very deep into Python, not into like those waters where I'm teaching you things that you never knew existed, but more in the world of using Python, but specifically using it to crunch some finance data. So in our session one, which we are doing everything on Jupyter Notebook, we started by covering some Python basics, and we went over, like data types, but we used terms which are more favorable about stocks, about markets, shares, all those things. Then in the session two, we actually dived a bit more deep into that world, and we ended up by using some libraries that are available for data science, which is like pandas, numpy, matplotlib. Learned what is data frame, learned about numpy, did some numerical calculations, plotted charts actually, which was an interesting one, right? Sorry. Then we started doing a mini Hello Finance project where we learned about random walks, we learned about normal distribution, we learned about what is a cumulative sum, and then we saw like made a chart, actually plotted a chart, not a made chart. We plotted a chart of a cumulative sum of stock price, which is a fake stock price, okay, something that we randomly generated. Then we also plotted something which is a random walk with no cumulative sum, so it's more of a normal distribution kind of. And then we plotted a graph of this versus that, and then we started reading real financial data from CSV files, which I think I forgot to push. Oops. uh, Let me do that very quickly. Okay, let's go back, let me reload. Okay, yeah. Then we dived into the world of real financial data. And I say real because this is actually real. This was the data from 7th of February 2024 to 7th of February 2025, okay, of Apple, JPM, that is JP Morgan Chase, and MSFT, which is Microsoft. Okay, so we saw some real data. We read it from CSV files, which are actually stored in the same folder. Okay, so we read some CSV files. We'll use pandas for doing so. Then we did some not calculations, we did a dive into how do we read these files, what tools are available to us, like describe, shape, columns, data types, what is unique, how many of them, uh, how many times something is repeated, all those things. Then we looked into merging data, so three different data frames, like think three different CSV files getting merged together is what we did, achieved using pandas. After merging them, we plotted them using matplotlib, and we saw that while it was nice, it was very much like question, and we kept on increasing the size of the plot, but it was just not enough. So that is why we went to the next bit, which was to use plotly for doing so. And unfortunately, it seems like I am missing the figure for that. So let me get this one started. So we know that we do Jupyter Notebook. Once that starts up, session 2, iPine Notebook, and I'm going to do kernel, restart, and run all cells. And that should run everything. And very soon we will have an output. So this is what we ended up with. Now, the good part of this was that you could actually zoom into things. So like example, I say that I want to zoom into the data of these many days. It would also change the axis. Okay, so that's what we achieve with Plotly. You saw how powerful it is to actually look into some specific data. Interactive, that if I go over like every day, it would tell me the date and the stock price along with the ticker that you see, MSFT. This one is for Apple. This one is for JPM. Okay, so all those things could be easily seen. I can dive a bit more into details, and then I have data of nearly every day being seen. Okay, and you can pan by going like left and right, and if you double click on this whole thing, it just collapses down to original form. So that's our merged data. And before going on, like before the last session ended, I had promised you, like we'll talk about what is scatter. So this is a type of plot actually, which is a scatter plot. There are multiple types of plots that exist in Plotly Python library, I would say. So like scatter plots, line charts, bar charts, pie charts, bubble charts, like lots and lots and lots of them. So in our case, we used a scatter plot because we wanted to basically plot multiple markers. Okay, excuse me. So yeah, we wanted to plot multiple markers individually. So individual data points, you can say. That's why we use scatter plot. Uh, the other thing is like this one, definitely it's the x-axis value, this is the y-axis value, and then this is the lines plus markers, that is the mode. It is used to show both the line and the marker, which is like right now, if you see, if I go into the zoom, you see some lines and you also see those dots, those are the markers. So they exist, like let's say if you just want lines, you can also do like just lines. Oh, I'll have to run this whole thing again. Yeah, there we go. Sorry. It's like, why does it look weird? Okay, so this is just lines, and then you can always do just markers as well. Okay, so that is just those dots. And but I use lines plus markers because it looked good, right? So lines plus markers is the mode that I went with. And then finally there is the name option, which is, I think it's very understandable that it is the names. Mm, okay. Yep. So I think this is where we ended. And the fig dot show, this is to plot the figure. Helps when you are doing it in normal Python, not in, let's say, Jupyter Notebook. Like if, let's say, I think if I remove this and I start fresh, it should still show it. Okay. But this is for Python. Like when you put this code in a .py file, that's when it becomes much more powerful. If I'd say, yep. And finally, let me just restart kernel, run all cells, and let me go over to session2.py. Where did we stop? I stopped at the normal distribution versus cumulative sum distribution. Let me also add the next bits of code. So this is where I stopped, and this is the next bit of code that I wrote. So like, give me a minute. This is just so that you have the same code available in Python, so you can run it as a .py file. And ideally, you should, not ideally, hey, technically, you should always get the same result. We also saw like merging data. That was like next thing, next big thing for us. And yeah, I think this should be good to go. Yep. Save this one. And that's it. Good. Let me just quickly push this code so that we have the exact same thing that I have. Okay, so I think this should have updated. Okay, done. Definitely had a plot there. Yep. Okay, good. Anyways, so with this done, now let's move on to the next bit. I will share this again. Actually, it's the last thing that I shared in the chat. So now let's go and create the session 3 folder, and let's move on to the next bits. Okay. So what am I going to cover in the next bit? Number one is we plot OHLC, which is open, high, low, and close of the data. That's one thing. We'll use another, like, two libraries to do this. We will use the MPF. Okay. Uh, so what is MPF? It is a MPL finance library, and it is really good for visualizing financial market data. But we'll also try and achieve the same thing with Plotly, where we add a bit more interactivity that we know. So we'll plot candlestick, we'll plot OHLC, uh, yeah, these two things. And then we'll move to the next bits. So the next bits are going to be about some exploratory data analysis, okay, and technical indicators analysis. So we will see uh, how is moving averages calculated, what are some momentum indicators, uh, some volatility analysis like Bollinger Bands. Then we'll read, like not read, we'll write some code where we do some cross asset correlation. Okay, and we'll use some different data. Uh, like in my mind, I'm thinking Amazon, Google, Tesla. Okay, and we'll use the Y Finance, which is Yahoo Finance library, to download data of like last 3 years. So that ways we'll have loads and loads of data. Okay, so yeah, with that, let's get going. Hopefully, you all have Jupyter Notebook up and running. I am going to close and shut down this notebook so that we are back here. And I have cross asset code. We'll get to it. So that's when I'll explain it a bit more detail. But I was just giving you an overview of things that we will do depending on the time that we have. Uh, yeah. Okay, let's do a new folder right here, session 3. Okay. And once we get in, what we want is a new Python 3 notebook. But we know that we prefer using Jupyter Lab. So I'm going to click on that open, like that Jupyter Lab icon, or you can go into, where is it? I keep forgetting where it is. I think it's in edit. No. View. Yeah. View open in Jupyter Lab. Yeah. Okay. So I'm going to close this one. Going to go to this one, and this one will be called, I'm going to rename it to session-3.ipy notebook. Okay. Now, what's next? The next thing that I want to do is we'll have to re-import the libraries that we had in session 2. Let's do that very quickly. Uh, Once done, uh, also, for people who are joining for the first time, to save something, there's the save icon. But if your simple mode is on, it should auto save actually, I think. Uh, so yeah, keep an eye on that. And what else? Okay. Uh, let's continue actually. So the libraries that we will need would be pandas. So let me do import pandas as PD. Next one that we will need right now would be MPL Finance. So I'm going to do import MPL Finance as MPF. Uh, the next one that we will need for sure is import plotly dot graph underscore objects as go. What else? Import. I'll also import numpy. I'm not sure if we'll use it actually. Import numpy as np. Also, let me import matplotlib as well while we are doing everything. So matplotlib dot py plot as plt. I think this should be good enough. Like this imports nearly everything that I want for now. Okay. I'm not going to do the version numbers again. I think it's fine. I'm pretty sure it got imported. Next thing is, let's write some functions. So we'll write the first function to load and clean financial data. Okay. So def load and clean data. It will take in one parameter, which is the file. Then inside this, we will do some stuff. So number one is df equals to pd dot read underscore csv. So we are making an assumption that whatever file is passed to us would be a csv file. Okay, so pd dot read underscore csv, the file that was passed from here. And then we will say that it has a, like, at least from our data we know that it has a dates column. So parse dates equals to a square bracket date. So what does this mean? Okay, so the parse dates is for converting the date column into the datetime format. Okay, now once we have everything converted, we will say like for loop, which we had seen in the session one, for column, or like whatever you want to call it. So for column in these columns, so like for each column in these columns, which is open, high, low, and close. Okay, in this case, data frame of that particular column equals to pd dot to underscore numeric. Okay, so what does to numeric do? So it converts the data to a numeric type. Now we know from our data actually, so if I go over to the Apple data, then I know for a fact that, where it is, yeah, there are some columns. So open column, open, high, OHLC, open, high, low, and close. There are some rows where the data is actually a string. Okay, so in this case, when I do a to numeric on it, in that case, what we will do is we want to convert it to a numerical format. But sometimes it is just not possible when you have this data. In that case, we will say, we'll add a new parameter saying errors equals to coerce, which means that if you find any error in converting it to a numerical format, then just convert it to a nan value, which is not a number. So pd.to numeric df of call and errors equals to coerce. Okay, so for the time being, let's actually test this. So I'm going to copy all these three data sets. I mean, I could reference it to the another folder. Let's reference it to the another folder. Sorry about that. Okay, so yeah, we can coerce the error and say that, oh, if it is invalid, then just parse it to nan, not a number. Okay, now what I'm going to do is, let me also run this side by side so that it's easy to see it in action. So I'm going to do a print, and what should I print? I can print the df. So I'll come out of this and I'll print the df. So double APL, that is our variable, and we'll call this function load and clean data, clean with a small c. And in our case, where is the data? So the data is actually in the session 2 folder, right? So from session 3 we have to go one level up inside session 2 folder and then find the data. So I'll try dot dot slash, that should take me one level up. Then I will go inside the session underscore 2 folder and then slash apple.csv, and let me try this. Okay, after clean, and I'll add some new lines here and there, and let me also print this df before clean. Okay, now if I run this, so this is the before clean, where there was this dividend and it tried to convert the open to a numerical. It was not able to convert this one to numerical because, well, it is a number plus string. uh, so in that case what it did was forcefully converted it to a nan. So row number 252, okay, this thing got converted to nan, not a number. So that's what this line did for us. So before clean and after clean. I hope that makes it much more clearer. Okay. Now, the next step that I want to do is I want to drop all the NA values. Okay. So all the NaN values, I want to remove those columns. So let's do that. Why? Because, well, they're not helpful to us. So imagine from a graphical point of view, you would have disjointed graphs. You will have like until up until 9th of February, you'll have a line. Then on 9th of February, you will have a nan, and then 12th of February, you will have another value. So this does not really help us, and it also makes the graph look weird, could have errors, so many things. So in our case, we want to remove that. So let's do that. That is why we are going to drop it. So we'll use the drop NA values, and then we will say in place equals to true. So this in place equals to true, what it does is it ensures that the original data frame, which is this df, gets modified. Okay, so that we have the new df. So now let me print the after drop na, and let's run this. So after drop na, look at the indexes. You have 0, 1, 2, 3, 4. Okay, that the top one is fine. The bottom one, we had initially 251, 252, 53, 54, 55. 52 had this 0.24 dividend. That got removed and became a nan. And now we dropped that whole thing. So now we have 250, 51, 52 is dropped. And then we have 53, 54, and 55. Okay. So that is what the drop na does. So by using this, we are removing the values, we're removing the rows with like nan. Okay, uh, next one is like one last thing before we actually move into some analysis, is that I want to uh, right now this 0, 1, 2, 3, 4, this is the index column, but I want to make the date column as the index column. Why? Because that makes it easier. Okay, that makes it easier for the time series manipulation. This is because in our case, the date is a kind of a unique identifier at this point. Wherever it was repeated, which was like whenever dividend was awarded, that's when the date column was repeated. But now, after converting it to nan and converting it to like dropping those nan values, we now have a date column which is unique. So that is why I'm going to set it to index, and we could use df.setIndex on the date column. And again, I want to modify the whole thing. So in place equals to true. And let me print it out after index. So now if I do this, then that 0, 1, 2, 3 column is gone and the date column becomes a index column. Okay, that's the main column. And finally, I can do a return df. And we can remove all the print statements. But before that, uh, anything else that comes to my mind? Hmm. Okay, let me also confirm one thing. Df of date dot is underscore unique. It returns true. So that's how you can confirm if date is unique. But in my case, I'm going to just comment that out. Remove this one, remove this one, remove this one, and remove this one. Okay. Now let's see. Oh, oops. Questions. So there was this question which I said like once we get to it, I'll try and answer it. What happens? Another question. What happens if the date column has inconsistent date formatting or spelling errors in one? Oh, okay. So that's a good question. Definitely. Like, what if the format is not the same? So for that, we'll actually need to check the parse dates functionality. Yeah, this is the perfect time to actually see what does pandas do. Let's go there and let's search for parse dates. Yep. So parse states, this is what it is. And normally it tries to do this. And for non-standard date time parsing, use to date time. So if you don't have a standard date time parsing, in that case, you will have to use this. But normally, I think the ones that you suggested, which was between this and this, I think it should ideally be a standard date time parsing. Also, it also says here that if for some reason it is unparsable or it is not able to parse it properly, it would just return the way it is right now. Okay, good question. Not exactly 110% sure about the answer, but ideally either it would return the same thing or it would try to convert it if it is a standard date time format. Uh, if it is non-standard, use the to date time. Oh, this is when I was coughing. Okay, thank you so much. Uh, there's this question. What do the nans in the before clean df represent? So the nans in the before clean df in here, this represents missing values. And in the after clean one, it converted this one to a nan as well. And the after drop na, it just dropped it. And after index, it just removed this index column. Oh, sorry about that. But I think that was a good question, and anyone else who had the same question is now answered. And perfect. Thank you so much. Thank you so much for all the questions. Really helpful. Just remember that by asking questions, you are helping everyone on stream. So thank you so much for that. Okay, so now I think after removing all the print statements, we are, yeah, we have everything that we need. Okay, let me also load the other two data sets that we have, which is the JPM and MSFT. So this I'm going to rename to JPM, and this would be MSFT. They are coming from the same folder, so should be fine. And okay, so if I now do Apple, there we go. JPM, there we go. And MSFT, there we go. Okay, so this is what our current data set looks like. I also want to confirm one thing. Hopefully everything should be unique, and yes, it is for all three data sets. The date column is unique after the dropping NA and converting to like converting to NA and then dropping it. Okay, so okay, that was one last thing that I wanted to check, and I've shown you what it looks like right now. And what else? Okay, now let me actually delete all of this, because they're not, that was just for showing it to you. Okay, so we have our three data sets. Let's create a few ones. So now we want to select the OHLC columns for each data set. So OHLC, as I said, actually I think it at least have one. Okay, so currently our columns are date, open, high, low, close, adjusted close, and volume. Okay, so this is our columns, but we want to select specifically OHL and C, open, high, low, and close. Now, open, high, low, and close, it represents the price range of a stock or a share or spot. Okay, that's also a terminology that you may hear a lot, that what's the spot rate. Okay, the spot rate, uh, that is the current rate, and spot price. Okay, that's also a term that you may hear, spot rate, spot price. Yeah, so spot rate, spot price, which is the current price, but we are interested in like what the current price, what did it start with, that is the open, what is the highest it went on a particular day, what is the lowest it went on the particular day, and what did it close at. So if it started at, let's say, 10, went high up to 15, went low to 5, and closed at 11, then what do you think? Did we make money on that day? So is that a green or a red? Okay, so that's a question I'm going to leave you with right now. Is it a green or red? You started at 10, went till 15, dropped to 5, closed at 11. Okay, so is that a green or a red? So you don't have to answer it right now, because we'll also plot it and check what happens. Uh, an open, high, low, and close, they tell you each day's price movement. So they tell you how volatile the stock was on one particular day. Okay, and you can do this for every day to see how much is it moving up and down each day. Okay, generally, and then you can make trends. That's how you predict the trends, by checking how much is the stock moving up and down each day, and how much of it is being traded. Okay, that is the volume. Like, is someone trading like just 10 stocks every day? Someone trading 100, 1,000, 100,000, million, whatever. Okay. So let's create these variables. So I'm going to have a OHLC underscore Apple, and I'll pick up the columns, not all of them. I want specifically the open, high, low, close. So similarly, I will have for after Apple, we'll have JPM. It should be from JPM, of course. MSFT and MSFT. And let me show you OHLC Apple. This is what we are left with. So we have kind of sliced the data. So there is one answer here about my question. 10, 11 is it's going to be green. Okay, let's see that. Okay, so in our case, so yeah, let's start by plotting it out. Now, the plot that I want to show you is going to be the OHLC plot. Okay, so to do that, we will use the MPF, that is MPL Finance library that we created. Not sorry, did I say created? Nope, we did not. MPL Finance library that we imported. So MPF.plot, and inside this we'll give it the data. So in my case, I'll give it OHLC underscore Apple. That's the data. Then you can define the type of the plot. So I will say it is the type OHLC plot. Then you have something called as style, and the options are Charles, Classic, Blue Skies. So let's go with Charles first. You can have a title, of course. So I will say OHLC chart, Apple OHLC chart. Then you can give a label on the y-axis, let's say. So in my case, I give it price. And let's plot this. So this is the Apple OHLC chart, but it is too small. It is really, really, really tiny to actually see anything. Okay, everything looks so squished, and it's not even interactive. So let us go for a bigger size, which we could go with fig scale equals 2.0. So we are saying that scale it twice the default size. So if I do that, better looking. Okay, zooming in is a bit nicer, and this is what it looks like. So you see these small bars. Actually, let me make it 3 times the default size. Yeah, there we go, much better. So now if I zoom into it, you see these bars. Okay, so this was your open, this was your high, then the bottom part is the low, and this bar is the close. So now let's check this. If you started here, if you opened here, you went to some high, you went to some low, but you closed more than your open, you are in a green. Now let's look at this red one. You started here, open, you went high up here, which was like this day's high, same. You went low down here, okay, all the way here, and you closed less than your open. It's a red line. Okay, so that is your open, high, low, and close. Okay, so that is for Apple. So this is what happened for Apple. And while this is nice, I'm pretty sure we need an interactive one, because this zooming in stuff is a problem. But this is a very nice one if you want to actually uh, put it somewhere. Okay, save it as a screenshot or something. So that is one of the uh, one of the things that you could do. So in our case, if I add a save fig equals to apple underscore ohlc chart dot png, actually ohlc underscore chart dot png, and if I run it again, okay, nothing happens here. But if I go back to home, I see that there is a new file here right now. Okay, which has saved a png, should also be available right here. Okay, much better. Like you can zoom in how much ever you want, but you end up getting a nice png of something. So that is our ohlc chart, and we also use mpf. So now another thing that I want to show you with mpf is a candlestick chart. So I'm going to remove this line because it always will keep saving over and over, and I'm going to copy this, and let me change the type from OHLC to candle. Okay, this is fine, and this would be a candlestick chart stick. And let me run this one, and this is your candlestick chart. So now if you look at this, so what does a candlestick represent? Any ideas, any answers before I answer? Mhm. Okay, so the thickness is more often the price range where it moved the most. Okay, so actually if I have to, like, let's focus on this time between September 13 and July 3, and this candle. Okay, that should be same here. Okay, so this low, this high is same as this low and this high. What mat And what about the open? Okay, the open and the close, what happened there? So let's go back and see. So open was right below this, close was somewhere here. Open was right below this, close was somewhere here, and the price did most movement between this. Okay, this one was an exception that was reached. This one was an exception that was reached, but generally the price fluctuated more between this. Okay, and that is why the thickness. So that is what the thickness represents, where the price moved the most. Okay, every and these smaller lines is more like an anomaly that happened in between of the movement. Okay, like for this day, it opened here. So like let's compare this with the exact same thing. It opened here, it closed here, and that's it. Okay, no anomalies on that day. Everything moved between that. The whole price actually moved between that. Okay, most of the times. That's it. No anomalies. So that is what thickness of the candlestick would represent. Okay, this is too zoomed in. Okay, nice. So this is Apple candlestick chart, and this is the Apple OHLC chart. And normally on any website that you see, this is what you are actually seeing. Okay, so you can always say, I think the more thicker the candle is, the higher would be the price range most of the times, I think. And I would say that the thinner the candle is, the lower is the price range. And the color represents the price movement. Green is normally a upward price movement. Red is normally a downward price movement. Okay. And what else? The lines above and below, they represent the high and the low. So these are the four things that we learned about candlesticks, I guess. Anything else that comes to mind? Not to me, actually, about candlesticks. So your red is, yeah, on that day it basically closed lower than it's open. Okay. Uh, Green is that it closed higher. The thinner part is basically, uh, you can say that it reached that high, it reached that low, but most of the movement was between those thick parts. Okay. So the thicker, that is the higher price range. Like more people were actually buying at those price ranges or selling at those price ranges depending on red and green. uh yeah, I think that should help in general to understand about the candlesticks. Okay. Okay. uh what else? Okay, let's also plot the exact same things for the other two ones, okay, before we move to plotly. So this one would be now jpm, jpm, and I'll copy this. Okay. And instead of this, I will go with candlestick. Okay. So that's the candlestick chart of JPM. There's a disjoint here in between, which we can check in with interactivity later. Uh, what's next? There is MSFT, right? OHLC, Charles, MSFT, OHLC. Going to copy this one and candlestick. Okay, there we go. So these are all the charts that we kind of needed. JPM OHLC, JPM candlestick, OHLC, and candlestick. I told you that you could have different types. So there is the style Charles. You can have different styles. Sorry, Charles. There is a classic. Okay, and this is the classic one. And there's also, I think, something called as blue skies. As the name says, it's blue. Okay, perfect. So I have, you can have this one in blue skies as well. Okay, doesn't help much. Does not make any sense. So it's good to have that in Charles. I wanted to see what happens in classic for OHLC. I don't think I've seen that. Okay, I think just grayed out. Doesn't help. So this and this. Okay, perfect. So blue skies helps for candlestick. Definitely does not help for OHLC. Uh, but the classic is also good. This is a green, and this is this. This one's dark, which is actually this red, and this one is red, which is this one. Okay. Sure. Okay. What else? What else? Any questions? Oh, so there's one question. So the thickness represents volume? No, not really. So wouldn't say volume. I would say it represents how much has the stock moved. Now, let's say I need to find something. Okay, yeah, let's say these two things. So this one is thicker than this one. Okay, and let's go and see its equivalent in OHLC. Both of them are red. Okay, both red right here, and there is one in between here. There is one green, two reds. Okay, so this is the one that we are focusing on. Or actually, let me make it uh Charles. So why do we even need to go up? Okay, this one. So this is red. This is red. You see the thickness of this is more than the thickness of this. So the thickness tells that the stock price moved a lot. So if the candle is very thin, the price did not move much. There was less volatility into the price change. Okay. And if it is like it can get thicker than this, let's say, then it means the price moved higher a lot. If it is very thin, the price moved lower a lot. Okay. And depending on the color, you can see that at the end of the day, did the price move up or did the price move down? So green is that the price went up, the red means the price went down. Does that make sense? Okay. Now let's plot this exact thing using plotly actually. So probably that would be a bit more understandable. If I do fig equals to go dot figure. Okay. And now next is fig dot add underscore trace. And inside this, I am going to go for OHLC. Okay. So let me first try for go dot OHLC. The x-axis, it would be apple dot index. We'll plot the open, apple of open, the high, apple high, the low, close, the name of this chart, which would be apple OHLC, And next, we can add a pic.show, I think, should work out. What am I missing? Oh, fig.update layout. Oh, yeah. Sorry, I was missing the capital O. My mistake. Uh, Inside the update layout, actually, I want to set the width and the height. So width, I want to be like 2000, and the height equal to 1000. And okay, much better looking. So this is the OHLC chart, and now I can do a zoom on particular dates. And now if I hover over it, the date, sorry, the open, the high, the low, and the close. Okay, it shows this down arrow saying that, oh, it closed down than the expected. But this is the up arrows. Okay, much better. Okay, and you can actually move this, or also even zoom from this. Okay, like show more data, not zoom, but show more data. uh, Kind of zoom in like this. uh, Move this around to see the data of multiple dates. Yeah, and just zoom out, and this is where we end up. Okay, what next? We can now plot just below this. I'm going to copy this one actually, and I'm going to plot it candlestick. Okay, right below this. So go dot candlestick. This is fine, this is fine, this is fine, and this would be candlestick. Okay, so this is the candlestick chart of. So now if you see, on June 12th, the open was at this, the high went to this, the low went to this, and the close was more than open. Open was 207.37, close was at 213.07. Okay, and yeah, this is basically our candlestick. And we can also move around here to see what is happening across, and zoom out a bit to get a holistic overview of the whole thing. uh, okay, I wouldn't say whole thing, the width is too much. It could reduce the width to 1800, and that should kind of capture the whole thing. Yep. I think you would need to add a title here. Title is Apple Candlestick. Yeah, that comes in right here. Apple Candlestick. And in the above case, this would be Apple OHLC. Okay, so yeah, we kind of got everything done with iPlot as well. Uh, okay, let me see if there are any questions. Oh, There is one question. Still confused about what does the thickness of candlestick tell us? Okay, let me try and think. So let me think. Mm, I'm trying to think of examples. Okay, so give me like 1 minute. Okay, like first thing that I want to clear that candlestick does not represent volume, okay, in any way or form. To see volume, normally you have those bars right below here. Okay, uh, so that's the volume. So remove the volume from picture. Okay, now thickness. Uh, it's just very difficult to find some data to actually show it properly. Probably that's why it's very confusing. Is this one good enough? Let me actually look through the data. Give me 1 second and I'll try and find some data which makes much more sense. Okay, I think I understand where the confusion comes from. Uh, hmm, okay, so the thickness, uh, yeah, I think this would make much more sense. And let me find if there is anything that I can find on like any links to something. Investopedia, probably. Yep. Okay. I think this link should help much better. And my bad in not exactly explaining it properly. So let me give it another try, and hopefully this one would make much more sense. So the thickness, I think I also wrongly said that, but the thickness is this, okay? This up to down, not this one. Not the x-axis thickness, but the y-axis thickness, okay? I think that's what I wanted, or probably definitely wrongly explained. Example, which one we were looking at? There were two reds and one green in between something. This one, okay? If I go down a bit here, okay, can't really find it. Coming back. So let's say this proper one, okay? Look at this one. And I need a mixture of red and green. So there is the thickness is this, okay? So okay, I think this makes much more sense about why I did it wrong, or at least showed it wrong. So this is the thickness of the candle. This is the thickness of the candle. This is the so the vertical. So in candlestick, the thickness or the body size, as we call it, would be measured vertically. So it represents the difference between the uh, high and the low. And as I said, there is this part which is thinner. There is this part which is thicker. Okay, in general, in the candle. So example, let's say this part. There is more thickness on the upper side, and there is less thickness on the lower side of this, right? So are you following me till now? So thickness. So I think I'm used to this mouse movement. Probably that's why. So thickness, and this is the thickness. Uh, Sorry. Okay. So now in this case, let's go through these four, one, two, three, four, five candles. Okay. Let's go through these five candles. Now, when I say that it has a large and thick body, which is this part, or actually this one, sorry, this one which would be much better suited, I think. So there is this part, long and thick body of this one. So this means uh, if the more like this part of the body is green, okay, so this means that there was a lot of buying pressure, okay, like more people wanted to buy this stock. And that is why what happened is that, the price moved from this open to this close, okay, with lots of people buying in between this range. There is this teeny tiny, very thin part of the body, which means that there was a buying, okay, and the price actually went up till this high, but that was very minimal, okay, like not many people were buying at that point. In this case, what happened was that there was a lot of selling, okay. So yeah, there was a selling here. It opened at this high, it closed at this. But you see this thickness versus this thickness, okay? Imagine this one versus this one. There was a lot of buying pressure. So the price fluctuated a lot. And that's why I think I used the term that the price range changed a lot, okay? Uh, so the candle is thicker here. It means that the price moved a lot and in the positive direction. This candle is thinner here, okay. So the price actually did not move much, okay. The open and the close are very actually like close to each other. At one point it did go up high, and at one point it did go like slightly low, but in general there was not much movement in the price. There is a thin body, this is a thick body, this is a thin body, and even in the same candle you can kind of say, oh yeah, uh, actually no, like let's not confuse that. So this is the thinnest body right now in between these all. Nothing much changed between the price. And if we can actually find the date of this is in December 8 to 15, uh, in here, so let me move this. December, did I say there? 8 to 15? Yeah, 8 to 15. Oh, actually, I can see it here. Sorry, my bad. Forgot about that. So it opened at 247. The high went up to 249. The low was 246, closed at 248. Thin candle, not much price changes. This had a fluctuation. Look at the open 241, close at 246. Definitely more fluctuation. Okay. So thick candle and thin candle. Does that make sense now? So we can't say about a lot of people, like, again, lot of people buying, lot of people selling would also mean volume, like, not exactly volume. It would be the amount of stocks that's being bought and sold. Okay? But generally, you use a candlestick pattern to see where the pressure lies. Is it more on the buying side or more on the selling side? And you can read more about candlestick patterns in that link. Like, let me open that one. Why is this untitled? Definitely named it session 3. What the heck? Weird. Okay. So going into candlestick patterns, you can actually see like high price, open price, close price, low price. So this is a lost one. Uh, because the open is here, the close is here. And this is a profit making one. In our case, it's easier to understand because we have red and green. Okay. Uh, and everything else is basically a pattern of how the candle is moving. Okay. Is it a bullish candle, a bearish candle? There is a hammer pattern, which is this one, three separate hammers, all signaling a bullish reversal. Okay. So notice the long tails. It means uh, the sellers tried to push it lower, but the buyers eventually won and they pushed the price up. Okay? So definitely more patterns right here telling you, oh, what's happening. This is a hanging man, suggests a downside reversal. Okay. So the thickness of, like, let's say this green one, based on, yeah, based on what we learned right now. Okay. What does the thickness mean here? So the thickness represents that if it is green, okay, if the it is a thick body and it is green, then it means that there was a strong buying pressure and the close was much higher than the open. And if the thickness, if it's red, and the thickness is like uh too much, if there's too much thickness and it is red, then it means, so this one, okay, so too much thick, or actually this one's much better. It is a thick candle and it is red, then it means that there was a strong selling pressure. That means the close was much lower than the open. Okay, fell down a lot, and the price range had changed a lot. The more the thick, that's how much the price fluctuated. So if you look at this green, it is a thick candle, and the price, and since it's green, then it means the price moved up a lot. The price range in the profit side, in the green side, like, means that the open was here, the close was here, and the price ranged a lot in thickness, like changed a lot, fluctuated a lot. Now let's talk about thin candle. So this is a thin candle. This is a thin candle. This is slightly thicker. This is a thin candle. This is a thin candle. This is a thin candle. So a thin candle represents that there is not much movement, okay, uh, between the prices. And that, like, if let's say this was every minute's price, okay, every minute is too much. If this was every 10 minutes price, then in that case, you can look at it and you can say that, there's very less price movement happening within that period. Like, no one's able to make a decision, should we buy this stock, should we sell this stock. So normally you would ideally see small bodied candles after large bodies. So when the price has moved up a lot, has moved down a lot, okay, like there has been a thicker candle, after that you normally see thinner candles generally. Okay, so very thick, thinner candle. Okay, compared, like this is very thick, a comparatively thinner candle. This is thick, thinner candle. Then when you have too many thin candles, then you have a suddenly there is someone who wants to buy a lot, someone who wants to sell a lot. Then you have thicker candles. So that is kind of a pattern that you would observe. Hopefully that makes sense. We talked a lot about thick candles and thin candles, and you can also see more about, yeah, there are other things that exist. Okay, I think that's too much time spent there. We'll move ahead. Ah, appreciate this, and you're welcome. Actually, I hope made much more sense. Okay, definitely read the article in Investopedia. And now let's move ahead finally. So we have done the MPF plot, we have done candlestick plot, we have done OHLC plot. I think that is good enough. I have not done it for all the stocks or like the plotly one. Okay. So let me actually add, this is where we started plotly, right? Okay. And okay, let's move to the next bit. Now, the next bit that I want to cover, and I don't think I'll be able to cover the whole thing in this session, but I'll try my best to cover as much as possible. So, yeah. Now, the next thing that I want to cover is going to be about a bit more. Like we'll write a few more functions, and we'll test out a few more things. Okay. Let me actually push this and also add a homework for you all. Yeah, I feel like a teacher sometimes. Homework, draw charts for JPM and MSFT using Plotly. Check out the Plotly documentation. So there are these charts and there's a financial chart. So I will say check out all the different financial charts that exist. Check out different financial charts that exist and try and plot most of them with a write up of what they represent. And the link to the documentation, okay, is right here. So I think that would be your homework kind of, or basically practice this out. And now let's move to the next bit. Let me push this, everything that we have, do a quick save. Uh, what happened to my session do.py? We did a scatter plot, and after scatter, did we yeah, we did do like a lot of things. Uh, no, we did not do anything here. Yeah, I have to create a fresh new session underscore 3.5. Okay, so this we did, then we did this, then we did this. Oh, got one line in between. Okay, then we did this one, then we did this one, and then I finally added this homework. Okay, so these are all the things that we did, not using these two libraries, but that is fine. And let me push this. So I'm going to do git add, git commit dash m. What did we did? What did we do? Sorry, uh, OHLC and candlestick. And let me do a git push. Okay. So now if you go to the GitHub repository, you should have session 3 as well. Okay. So session 3 should be right here. It should contain the chart that we actually downloaded, the notebook with the outputs for most of them, except for Plotly, and the code again. Okay. And now let's move to the next part, as I said. So the next part, let's go back to our this one notebook and let's start fresh. So the next part is about advanced time series analysis. Okay? So I am going to convert this one into a markdown as well. And this one is advanced time series EDA and technical indicator analysis. So what we will do. So in this part, we will learn about price trend analysis using moving averages, momentum indicators, RSI, MACD, okay, uh, volatility analysis, volatility analysis, specifically Bollinger Bands, and I will just say etc. right now. Okay, so let's start with some work directly, and as we write code, we will learn about things. Okay, so step one, we want to use a new library, which is the Y Finance or the Yahoo Finance library. Let me do import Y Finance as YF. Okay, and let me see if I can import it. Yes, I can, which is nice. We want to import Plotly, but this time I want to import the Plotly Express, not the graph objects. Okay, so import plotly.express as px, and what else? From matplotlib, I want dates. So that is another thing that I need. Matplotlib dot dates as mdates. We need pandas, but that is already imported at the top of the file. That should be fine. So these are three new imports that we need for this session. So step one, we will define our stocks. Now, in our case, like in this part of the session, I want to go with Amazon, Google, and Tesla. Okay, so these are the three stocks that we will analyze. We are using these tech giants because they have like different market caps and different volatility profiles. Like Tesla was down for a very long time and suddenly it's up. Uh, So this is our stocks. Next, let us download the historical data. Okay, sorry about that. Uh, okay, give me like 1 second. I need to do something. Sorry, back. Okay, so yeah, we want to download the historical data using Y Finance, that is Yahoo Finance. It's a library that we actually added at, I think, in session one directly. And we'll use like 3 years data with like every day's data. Uh, like that would be our interval. And that's it. Okay, let's start. So I'm going to create a data dictionary, which is empty for now. Next is for ticker in stocks. Okay. So for each of these ticker in the stocks, you can name this anything. Okay, this is just a variable naming. Uh, you can name it anything, but it's good to name it something that makes much more sense to someone who's reading. YF dot download. It needs the ticker. It needs the period. So in our case, I will say I want 3 years of data. It needs the interval. I will say every daily data is what I want, and that's it. Next is df dot reset underscore index, and I will say in place equals to true. So I'm going to convert, like it will have a dates column. I'm going to convert that dates column to a index column. So that would be our index column, node 0123. The date would be the index because we're downloading data of every day. So every date would be unique, of course. Uh, for that. And then I'm going to say data underscore dict, okay, for each ticker. Assign the df to that. Then I will say that print out the, like using f strings, wrong place, f strings here, f strings. Also, is this zoomed in? Yeah, much better zoomed in. So print out f strings. Uh, I can add a backslash n, and this would be ticker data, close ticker data, and first 10 rows is what I want. And to do print first 10 rows, we know we could do df.head, but in bracket we have to add 10 because default is 5. So now if I hit enter, you see the progress, one of one completed, one of one completed, one of one completed, and this is what we get. Okay, so there's the price, date column is here. Why is it not indexed? Interesting. I'll have to see it again later. Uh, but yeah, mostly we have the data. There's a ticker, which is a very weird one. Uh, this is done. What happens in the data deck? Okay. Oh, it's here. I was like, where is the bracket? I couldn't find it. Yeah, there's the bracket Amazon, and the value is the data frame of that. Another key is Google. The value is the data frame. Another key is Tesla. The value is the data frame. Okay. It's very weird looking. So for the timing, let's ignore it. And okay, so we have downloaded the data of like 3 years. Okay, 2022 is what I see here. And I can also print the last 10 rows. And for that, I can do tail. Okay, so 7th Feb 2025. The first 10 rows are from like 8th of Feb 2022, and the last 10 rows are like 2025. So we know that the data is correct. Perfect. Let's move ahead from here. So what's next? The first function that I want to create is to calculate the RSI. Okay? Now RSI, what does that mean? Now this is okay. Yes, I'm on screen. RSI. So RSI is like the full form of RSI is relative strength index. Okay, relative strength index, and it is a measure of how fast and how fast far, how fast and how far. So how quickly and how far. I don't know any other word for far. Uh, a stock price has moved over a given period. So it gives, and what does it tell you? It gives you an idea whether the stock has been like overbought. That means there is like too many people buying it, and like there is a potential of pullback. Okay, or if it has been oversold, that means too less, and there is a potential for a bounce. Okay, that it would go up. So RSI tells you if the stock has been overbought or if it is been oversold. Okay? Overbought or oversold. RSI values. Okay, now how do we calculate it and how does it work? So RSI values range from 0 to 100. So if the value that comes out, because there is a mathematical formula for it. So if the value that comes out of that mathematical calculation, if it is above 70, then it means that it has been overbought and there could be a chance of correction, or basically the price falling down. Chance. Okay, that's very important word to understand. There's a chance of correction. Similarly, if the value is below 30, if above 70, it has been overbought, and like too many people have that stock, and there is a chance that they will sell it off. So there is a chance of correction. Or if it is below 30, then it means that it has been oversold. Okay, like a lot of people have shut down the stocks and they have said like we don't want it. So there is a chance again that excuse me, that the stock has is become undervalued. It has potential, but for some reason, because it has been sold a lot, the price has gone down, and there is a chance that it will rebound and come up. Okay? Any questions so far about RSI? So relative strength index. The word says that it's relative. Okay? So relative means that you check between certain ranges. Okay, so normally it is calculated over a 14-day period. And what do you calculate? You calculate the average gain and the average loss. So RS equals to, so relative strength is equal to average gain over some period of time, let's say 14 days, divided by average loss. And now to convert that to an index, okay, the RS will give you some value, which is relative strength. But if we want to convert that to an index, so the formula is RSI equals to 100 minus, I think, I think RSI equals to 100 minus, and now in bracket, okay, 100 divided by 1 plus RS, where it would have added this in comments. So this is RSI, okay, 100 minus 100 divided by 1 plus RS, where RS equals to average gain divided by average loss, typically over 14-day period. Okay, so what does it again help us with? uh, you're missing one. Oh, okay, you actually have it. Sorry, I read it wrong. How fast and far a stock price has moved over a given interval tells you if the stock is overbought or oversold. Yeah, kind of true. uh, Okay, so the next bit that I want to say, like, why would you use this? So traders would look at RSI and they may decide if the stock price could change. Okay, that in the last 14 days, 14 days, 14 days, like they do it, like let's say three times, and they see that there has been a lot of selling, and uh, the RSI has fallen down, like, is less than 30. They might think, or they might take a chance that there is a possibility that this will rise up. So let's buy the stock because the price might rise up in the future, right? Like in the near future. Or if they see that, oh, in the last 14 days, the next 14 days, the next 14 days, uh, 14 days, and then one, and then 14 days, then one, then 14 days, that way, and it has risen above 70, then they might, and if they own the stock, they might consider selling it because there is a possibility that the price will now go down. Okay, what else? Also, if let's say you calculate an RSI and the RSI says that it is above 70, okay, and you sell it, there is a possibility that the stock price rises above more. Okay, when it is above 70, normally you sell it because you think that it will go down. But what if the stock price actually goes up, and then you think, okay, now it's again above 70, let's sell it again. You sell it, it goes more up. So this means, so there is a divergence here, and this means that the current trend that is happening is actually changing. So you should not calculate the RS, you should not rely on the RSI anymore for the time being until, like, new 14-day period starts. I think that's good enough uh, theory about RSI. Let's write some code for it. So we will do RSI calculation, relative strength index. Okay, so let's define a def calculate underscore RSI. It needs a series and the period, like over how many days you want to calculate. And I'm giving it a default period of 14 days. Okay. And if you don't want to run like if you want to create a function but don't want to add something to it, you can create a pass, like write pass here. So then it will not error out. Like if I do this right now, it will error out. And I can create a pass here, which means that I'm doing nothing. The function is created, but it's not doing anything. Uh, yeah. Also, uh, this 14-day period, I think there was uh, the name. I'll have to Google. I think something Wilder. Uh, yeah, J. Willis Wilder Jr. Okay, uh, that person introduced this concept of RSI. Okay, yes, and they introduced the period that it should be like over 14 days makes like over 14 days is like your half the month on, right? So over the first half of the month, what's happening, and then you do like 1 day ahead, 1 day ahead, and based on that, it's like an oscillator that's there. Okay, a line graph, a oscillator on a scale of 0 to 100. That's what we are going to plot or check or yeah, make a decision on. uh, and we can see that if it is overbought, like, or oversold, if it's above 70 it's overbought, if it's below 30 it's oversold. Okay, okay, now let's write some formulas for it. So def calculate RSI. uh, we will create a variable called as delta equals to series dot diff. Okay, we are also, what is the series here? uh, so the series would actually be the data frame, and data frame on a particular column. Okay, that's how we'll create. So it's a pandas data frame on a particular column. So we'll choose a column of a particular data frame. Let's say the current data frame, right? The DF right here. That's what we'll choose, and that's it. Yeah. Okay. So we'll find the diff, the dot diff. It basically gives us the price change. We'll create the gain, that would be delta dot clip lower equals to 0. This means positive changes only. Sorry, and less loss, not less loss. Gain and loss is, now I'm doing -1 multiplied by delta dot clip and upper equals to 0. So this means uh, negative changes only which have been made positive. Okay. So dot diff, it calculates the difference between two consecutive elements. So element at zeroth position, element at first position. Dot clip, it actually limits the values to a specified range. Okay. Uh, so in this case, in the delta dot clip lower equals to 0, we're basically saying that the lower bound is 0, and in the next one is again the upper bound is 0. Okay, we are doing a price reversal there because inverting the sign. Now next, let's calculate the average gain, and we can do that by taking the gain dot rolling and window equals to the period that has been passed. So like 14-day period or whatever, uh 15, 16, whatever period that you tell it, and the min underscore periods equal to the period. So this is the minimum, and then we find the average. So we do a dot mean. Okay, okay. So yeah, gain dot rolling. So rolling it, as I said, calculates the rolling window. Uh, so one, the next one, the next one, next one, next one, over a certain period. So one four like or over 14 days, we are calculating the rolling mean. Like we're doing a rolling calculation, and the minimum period, it sets how many minimum numbers of data should be taken into consideration. So in this case, we'll say that, since if let's say we don't change anything, then we say that over a 14-day period, take at least 14 days together and find the mean of it. Then you take the next date, you move one day ahead, take the next 14 days and calculate the average over that 14 days. And then next day, calculate the average over the next 14 days. And similarly for average loss, so loss, we are doing a sign reversal here. So we are converting it to a negative value. And loss dot rolling window equals to, again, the periods over like 14 days, and the min periods equals to periods over 14 days. Feel like I've written this so many times that they're like I'm hallucinating about the spelling. Okay. Uh here. Now the RS, which is the relative strength, it is equal to, as I said, average underscore gain divided by average underscore loss. And the RSI is equal to 100 minus 100 divided by 1 plus RS. Okay, so that is your RSI. And finally, we will return RSI. Okay, so that is the formula. Let's see this. Actually, let me run this. Okay, now let's see this in action. Okay, I will create a Tesla underscore df, and from our data dictionary, I want the Tesla key. And next is, for the Tesla df, I want to calculate the RSI underscore 14, and that is equal to this calculate RSI on one of the columns. Let's say on the closing column. And I'm saying the period is actually 14. And next is, I want to do a Tesla underscore df dot head 20. If I run this, this is what I get. So for the first 14 days, so 0 to 13, that's the first 14 days, nothing. And then it calculates for the 14th day that this is the average. Actually, if I do dot head 250, mm, I need more data to show. Uh, if you do ed dot set underscore option, and in here if you do display dot max underscore rows, and let's say set this to 250. So then I think we should be able to plot the 200. Yep, much better. Uh, okay, so let's see the data. Do I have to do this again? What happened here? Did I do? Oh yeah, finally it's here. For some reason it was nan and nan and nan for everything. RSI 14 added a new column. Nothing for the first 13 days. 14th day, this is the value. Then this is the value. It is uh above 30, as you can see. So at this point, you could say that it's fine. At one point, it goes above 70. Okay. So now this suggests that there would be a price reversal. Okay. So let's see. So when it was above 70, let's focus on this one. It was above 70 here. So there is a chance that it would go down. The price would go down. So which is a closing price here. So let's keep an eye on this one. Okay, where does it close? So here it was above 70. Next day it closed a bit low. Okay, this is the closing column. Focus on this one. Then this is 75. What happened next day? It actually went high up, 363. Then it went high up, 66, 64. Fell down, 359. Okay. 361 went high up, high up, high up. But now if you see right here, the last 14 days, the RSI says that, you know what, it's not above 70 anymore. Okay. That means it is not overbought. So RSI starts going down and look at the price change. Okay. This suddenly the RSI is 30. So now there is, and the price is 292 here, which means that it has been oversold. Now there is a chance that it will go above 292. So let's see what happens next. 292. And does it open high up next day? Actually, it does. 299. Closes less, but opens again high up. Okay. Closes less, but opens again high up. Closes less, opens lesser, but it closes at higher. So this is when the RSI was below 30, which means it was oversold, and there is a chance that it will be there would be a price reversal and it may rise. Okay, like a lot of people have sold it. There's a chance that it may come up, the price may come up, and that's what we actually see here. Okay, right here, 292, and this is the open, right? Yes, the open price. So the close on the previous day was 293. The open was 299. Oversold should rise, and it did, but it fell down the same day. Oversold, it did rise again, actually from the last closing, but fell down again. So if you keep going through this, we can write a formula to actually check when the RSI was like above 70, what was the closing price on the previous day and what was the opening on the next day. Let's find some more above 70. Okay, here. Okay. So right now, if it's above 70, it has been overbought and the price might go down. Okay, that's what we understand, right? It has been overbought and people might sell it, and that would trigger a low price, like price going down. Sorry, not low price, price going down. So let's see. 7064 right here. Okay, 247. Next day it opened up high, 255. It closed 271, which was higher. It opened up higher again, 276. So it's not exactly following this trend. Closed low, 272. It opened at slightly low, like 3 cents low, 70. More than 70, it has been overbought and it could go down. It did by 3 cents, okay, not much, but it actually went down at closing to 268, much lower, okay, and then it opened 266, which was lower, okay. So it does follow the trend slightly here, okay, 268, 266, and went down a lot. And now the RSI is less than 70. They don't actually see much. Let's see here when it is between the ranges of 80, 280.89, 280.70. It does go down a bit, okay, follows the trend of RSI, closes at higher though, then it opens at much higher, closes at lower, okay. So it did not follow the trend here, but let's see next. 297, it opened at lower, follows the trend, closes at higher, opened at much higher, does not follow the trend, closes at higher, does not follow the trend, opens at other high, does not follow, but closes at low. Okay, kind of follows it. Opens at much lower, closes at much lower. Okay, follows the trend between the states. Okay, so I think that is enough of follows the trend, does not follow the trend. Did does this make sense? The RSI over last 14 days, does that make sense? You can always change the period to be like, let's say, last over 7 days. Okay, calculated over 7 days. So first 6 days nothing, seventh day. Okay, so you can always like switch around the period. Like at one point it reached 100. That means it has been like over last 7 days it has been overbought, overbought. So there is a chance of reversal. Okay, and people will sell it and the price will go down. Doesn't happen here. Right before this, 331, 326. It does go down. Actually follows the trend right here, but then it does not. Okay, then it goes the other side. So 7 days not a very good period it seems. But you can calculate for 7 days, 14 days, 21 days, all those things. Okay. Okay, I think that should be enough from me. I am like, I have like 1 minute left. I don't think I'll be able to complete this for now. So we'll stop at RSI. Hopefully, the relative strength index made sense. The math made sense. The formula that we wrote made sense. I tried to explain every bit of it. Okay, what is a rolling window? Uh, Window period, the minimum how much you have to consider at a time. You can say like this could be like, let's say, 7. You can fix it like, oh, you'll be given data of 14-day period, but calculate the rolling window over 7 days. That's what you could do as well. Okay, and we saw it over the Tesla stock. Definitely try it on the Amazon and the Google stock. Okay, to see what happens. Okay, does it follow the trend? Does not follow the trend? Whatever we said. Okay. What else? Okay, I think that's good enough for now. Okay, thank you so much everyone for joining. I don't think I'll be able to complete this, so I'll end it here. And I will see you again tomorrow, actually, depending on which time zone you are in. But from the UK time zone, from GMT perspective, uh, I am online again for the fourth part of this session at 10 a.m. GMT. Okay, 10 a.m. GMT is when I'll be back again. In terms of ET time, I think it would be 5 a.m. ET. Okay, tomorrow 5 a.m. ET is when I'm online again. For the part 4 of finance with Python, where we'll continue this. We'll see, like we have calculated RSI, we'll see how to calculate a simple moving average, exponential moving average. Uh, we saw the RSI for momentum. Then we'll calculate Bollinger Bands, okay, and trend moving indicator MACD, that is moving average convergence and divergence. Uh, and we'll also plot all of these things, okay, to see how it looks on a graph. What exactly does it mean? For some people, I think graph makes much more sense. Okay, cool. Uh, you are absolutely welcome, and thank you so much for this. Now, before I leave, there's one last thing that I want you to do, uh, slash request you to do, which is provide feedback. So I am going to share the link in the chat. There we go. So please, should be very simple form. Should not take more than 5 minutes. Actually, go in there. Choose, like, this was the Python 3. So finance with Python part 3 session. Rate the content, rate what you liked, what you didn't like, anything that I could do to improve, all those things. So that would help me improve my session so that it's more tailored towards you. And at the same time, uh, if you write nice things, then I'll be happy, of course, that I'm doing good. If you not write nice things, then of course I'll be sad, and then I'll try to improve on whatever feedback that you provide. So take 5 minutes, fill this up, uh, and let you know about it. Okay? So thank you so much, everyone, for listening to me, and I will see you again in part 4. And I will actually push this. Okay, this time I'll definitely push this. Actually, let me do it right now. Do we have a session right now? Am I hogging someone's time? Uh, Not really. Okay, so I have like 5 minutes. Okay, let me do a git status, a git add, a git commit, and what did we do? We actually added RSI indicator and git push. Okay, so that should actually now have the latest code in the IPy notebook. Uh, won't have the latest code, unfortunately, in the Python file, but that is fine. Okay? Like, I'll change that. Uh, Let me also make a change very quickly. So I want this to be 14 days. Okay, and let me copy this over in the Python file. So first, let me copy this one in the session 3. Do try and do the homework. The second homework that I'm giving you is to calculate the RSI for Amazon and Google stocks as well. Okay? So please, please, please try and do that. Give me like 1 more minute and I'll be out of your hair. Uh, Kernel, restart kernel and everything. Okay, that's done. Okay, I'm going to save this one and this one. Format this, save this. Clear with add with commit, amend the previous commit so that it goes as part of RSI commit only, and force it. Okay. Okay. Now this should also have the updated Python code, okay, and the updated notebook code with a 14-day indicator. Okay, and once again, you can find all of this on my GitHub repository. Uh, you should have everything that I have done so far in here. And oh, well, welcome. I Yeah, thank you so much. And you're welcome. I would say work the repository so that you are in sync with whatever changes I push. Or if you're making your own local copy, perfectly fine. Okay. Good. Thanks a lot, everyone, and I will see you tomorrow. Yes. Bye bye. If there are no further questions, I'm assuming no further questions. Thank you so much, everyone. Yes. Bye bye. See you tomorrow.